We shall now take a look at a flowchart where we are going to find the sum of natural numbers from 1 to n. Let's try to understand what it is. In the previous flowchart, I showed you how to print numbers from 1 to n. Here what I'm going to do is, instead of printing the number, I was printing I in the previous flowchart. What I am going to do in this particular flowchart is, instead of printing I am going to add the value of I to sum. I am going to say sum is sum plus I. So this way the value of each of these natural numbers will get added to sum. The best way to understand it is, let's take a look at the logic and then go about with the explanation. So the first step, as usual, is the start. Alright. Now here I need a memory location called as sum so that that result can be printed here. So I'm saying sum is 0, I is 1. Alright. This is my initial starting point. So I'm going to add the value of I at every stage to sum. Now important thing is, I need to get the value of n. Okay, the user is going to tell me the value of n. So I read the value of n. As usual, the first question to ask is, how long should I continue to keep adding the value of I to sum? As long as the value of I is less than or equal to n. It can be true and it can be false. If it is false, we'll see what we are doing later on. If it is true, let us see what we are doing. If it is true, what I am trying to do here is, I am trying to take the value of I and adding it to sum. Okay, sum plus I. Then obviously I should go to the next number because I also want to add the next number to sum. I increase the value of I. Now as before, I am connecting it back here, alright, so that this fellow should keep going and doing this work again and again as long as the value of I is less than or equal to n. The minute I exceeds n, what I am required to do is, I need to print the sum. Don't try to print the sum in the loop because you want the grand total. You do not want the running total. So you want to do this printing at this particular point of time. Now as usual, the best way to understand this particular flowchart is, draw table and run through this. We'll again take a small value of n. Let's just take it to 3 because the concept is important, not the number of runs or the values. Sum is 0, I is 1. Let's say I read the value of n happens to be 3. Is 1 less than or equal to 3? It is true. So what I am doing is, the old value of sum, I am adding the value of I. 0 plus 1, sum becomes 1. I is increased by 1, so I becomes 1 plus 1, I becomes 2. I go back here. Is 2 less than or equal to 3? It is true. So I am coming here. Sum is sum plus I. The old value of sum is 1. 1 plus 2. Sum is now equal to 3. I should be increased by 1. From 2 it becomes 3 and it goes back here. 3 is still less than 3? No, but it's equal to 3, so it's still true. Sum is sum plus I. 3 plus 3, sum is equal to 6. Now I ends up becoming 4. Is 4 less than or equal to 3? Is false. I come here, I print sum. This is a parallelogram. I print sum. What do I print? Sum is 6. So 6 is printed as the output on the screen and then I stop. So this is the way how you go about printing numbers from, finding the sum of natural numbers from 1 to n. Suppose you had to find the sum of a series like this, 1 upon 1 plus 1 upon 2 plus 1 upon 3, like this all the way till 1 upon n. You would have simply made this I as 1 upon I. So you can try to find the sum of this series where sum is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3 all the way till 1 upon n. This way you will understand the process of how looping, iteration or repetition works. Because looping, iteration or repetition is absolutely important in programming, because all the code you're going to write of any significance is going to involve decision making and looping.